KPCL, a leading power corporation of state, generates power 24/7, from various sources of energy, like hydro, thermal, wind, and solar. Workmen of different divisions, like civil, mechanical, electrical, instrumentation, chemical, work in KPCL. For construction of new units, civil engineers are required. Mechanical engineers work with piping, erection, and maintenance of boiler, turbine, pumps, fans, etc. Electrical engineers are required for the maintenance of transformers, generators, exciter, transformation of generated power to the grid, and providing electrical supply to motors and drives for operating pumps, fans, and other equipments. Erection and assembling of equipments is one major task. The other major part is operating those equipments with precision and protection, with information collection, and efficiently controlled operation of various control loops for operating all equipments from a common centralized control room, that is, to achieve automation, for which instrumentation and control engineers are required. The biggest benefits of automation is that it saves labor, however, it is also used to save energy and materials, and to improve quality, accuracy, and precision. In any process, there will be some inputs to generate desired outputs, with some byproducts. The outputs are to be generated with desired parameters, irrespective of any changes, either in the inputs or in the environment in which the process is operating, with optimum efficiency, and at the same time, without foregoing the safety of equipments and personnel involved, and also without affecting the surrounding. To effectively achieve the above, many process parameters are to be measured, monitored, controlled, stopped, and started by providing suitable equipments, including mechanical, pneumatic, electrical, electronics, and computers, usually in combination, which is supposed to be done by instrumentation engineer, in consultation with the related process engineer. The advanced type of automation is feedback control, which is usually continuous, and involves taking measurements, using a sensor, and making calculated adjustments to keep the measured variable within set range. All the elements constituting the measurement and control of a single variable are called a control loop, which is accomplished with a controller. The automation system is used to implement closed-loop control, open-loop control, interlock, and protection, and monitoring. The intelligence of the system is distributed among several modules, each working independently with its own inputs and outputs. In the earlier years, the scope of instrumentation in power stations was limited to automation of main equipments like boiler, turbine, and generator controls. All other equipments and processes, like water treatment, ash evacuation, and disposal, etc., are being monitored by local manpower. But now, instrumentation and control is spreading widely across all the fields of power generation. Water treatment processes like RODM plant, PT plant, raw water system, clarifier, etc., are all equipped with automation system. Nowadays, coal handling system also needs automation of instrumentation and control system to reduce breakdown time of the coal feeding systems by accurately analyzing the faults in the system. For a plant, measurement system needs to be very accurate and reliable. Delays should be as small as possible. INC chain begins with sensors that detect process values like temperature, pressure, flow, level, vibration, etc. Controllers receive these values, upon which a control strategy is activated. The response, where and when required, moves in final actuating control elements to modify the process. This loop repeats over and over during plant operation through a complex and multi-level communication schemes. Changes due to process parameters are a common factor, for which the control loops are tuned by INC engineers to maintain the plant stability automatically with less variation. Loop control is normally accomplished with a controller. General-purpose process control computers have increasingly replaced standalone controllers with a single computer able to perform the operation of hundreds of controllers. An automatic controller, once properly tuned, will make the proper adjustment quickly to minimize upsets, and will control the system more accurately and reliably. The working of control loops can be well understood when the control loop is kept in manual for some reasons, where the operations staff has to be on the edge of seat. Online testing and performance monitoring can help a power plant improve efficiency, maintain a high availability factor, and generally improve plant operations. Central electric power stations are also undergoing rapid growth, and operation of new high-pressure boilers, steam turbines, and electrical substations has created a large demand for instrumentation and controls. INC engineers work hand-in-hand with operation team to maintain plant stability and allow plant operators to identify factors affecting the equipment performance. At any instance, for troubleshooting of problems quickly, INC engineers are very much essential. The alarm system is being modified as per the requirements and necessities. In case of operator fails to take remedial action for an upset condition, it protects the system by alarms and tripping. It also provides data on operating conditions before failure of the equipment for analyzing cause of failure. Main work of instrumentation engineer is testing, fault analysis, and commissioning of turbine control system, plant DCS system, like boiler, and BOP, and also control valves, motor-operated valves, solenoid valves, electrical breakers, servos, PLC, and SCADA testing, as an RODM process, ash handling plant, PT plant, jackwell pump house, and so on. Calibration and replacement of plant field instruments, as and when required. Testing and calibration of plant measurement circuits, pressure, temperature, flow, speed, position, and vibration probes. Testing and commissioning of plant analyzers like pH, silica, conductivity, phosphate, SOx, NOx, CO, dust emission, and oxygen analyzers. Graphics designing and modifications. Testing and tweaking of control constants, and minor, to sometimes major, logic modifications in application code to the controllers. Trends, reports, and sequence of events provides powerful executive information system to facilitate proactive decision-making and analysis of various causes of tripping, faults in system, and parameter variations. This also provides information to share and compare present, previous, and past unit performance data of their duration of operation to the operation personnel. Information of day generation, plant load factor, efficiency, specific coal consumption, gross calorific value of coal, heat rate, water consumption, total fuel, coal and oil consumption, and other plant informatives are provided by instrumentation system to operations staff on their monitoring screens, and can also be sent to remote computers and mobiles of senior officials of plant, and also to where it requires through RPDM. Instrumentation and Control Division of KPCL has a good amount of well-trained and hard-working engineers. Emergencies come uninvited. When there was fire in cable vault of BTPS on 17th of March 2013, thousands of cables were burnt, because of which feedback and command signals of all equipments and parameters were not available, and operation people had to rush to the local spot to check the condition of the equipments, and all equipments were supposed to be operated locally without any option, which was otherwise just a one-click task. In cable vault, it was a very difficult task to identify, segregate, and rejoin the burned-out cables. But INC engineers took it as a challenge, and worked day and night identifying the cables, tagging, cutting the burned-out cable, and rejoining it with a new cable. This hard task was completed successfully in just 21 days, with full efficiency. INC system plays a major role in the profitable operation of a plant by achieving maximum availability, reliability, flexibility, maintainability, and efficiency. These systems also assist in maintaining emissions compliance. Today, extensive automation is practiced practically in every type of process, which includes electrical power generation. C&I systems has resulted in increase in PLF and decreasing the manpower required per megawatt. C&I has very important role in stabilization of various subsystems of power plant through tuning and commissioning of various loops, performance monitoring of various subsystems, optimal operation of the plant at the target performance level, and preventing tripping and forced shutdowns of unit. Reduced direct human labor costs and expenses. Automation is often employed to improve productivity, quality, or robustness. To replace human operators in tasks that involve hard physical or monotonous work, and in dangerous environments, and to perform tasks that are beyond human capabilities of size, weight, speed, endurance, etc. Provides higher level jobs in the effective development, deployment, maintenance, and running of the automated process. As per the requirement of the corporation, instrumentation engineers are working round the clock to meet the demands of ever-growing needs of the existing and upcoming projects, thereby developing into an indispensable part of the thermal power station. through INC system, we can achieve safe operation of the plant, close monitoring of the plant parameters, and events for fault analysis. Lower the cost of generation, increase equipment life, minimize environmental effect, maximize efficiency, energy conservation. If any process has to work in automatic mode, then instrumentation and control is a must. Thank you.